Up next is a keynote on catalyzing semicon ecosystem, where our speaker will speak on the touch points, semiconductor policy, progress and way forward, India to be the next best destination for semiconductor manufacturing, and crisis, what the future holds. Our speaker is Vinod Dam, founding partner, New Path Venture, and co-founder and president of AlphaSeas. Vinod Dam is an Indian-American engineer, entrepreneur, and venture capitalist. He is also known as the father of the Pentium chip for his contribution to the development of Intel's Pentium microprocessor. He's also the founder of Indo-US Venture Partners, an India-focused venture capital fund, and also has mentored several startup entrepreneurs. Pleasure to have you here with us this afternoon. Vinod, over to you.
Thank you for the intro, Justin. I am logging in here from Silicon Valley in California. I want to express my sincere thanks to the organizers of NASSCOM for giving me an opportunity to present the policies developed for implementing an electronics and semiconductor ecosystem by the Ministry of Communication, Ministry of Electronics and Information Technology, under the vision of Honorable Prime Minister Modi ji. I will also discuss some of the key challenges we will need to overcome to realize this vision, and some progress that we have made in a short period of time since this policy was announced. India has identified 4 key overreaching policy goals. Number 1, to make India Atmanirbhar in electronic system design and manufacturing. Number 2, to set up domestic semiconductor chip and display manufacturing capability for meeting India's emerging needs in electronics. Number 3, to make India a global hub for chip design. And number 4, to develop domestic skills in semiconductors and integrated electronic packaging for making India a semiconductor skill capital of the world. Digital India is rapidly growing in its needs for electronics. In a country of 1.2 billion people, there are 1.2 billion mobile subscribers demanding smartphones and advanced communication services, cloud computing, and servers. Over 750 million people are accessing internet through their desktops, laptops, tablets, and smartphones. In a short span of 2 decades, India has grown to become the 3rd largest startup ecosystem, with a vibrant array of leading-edge startups and unicorns, gradually addressing the Internet of Things, electric vehicles, and industrial automation. Domestic electronics production is slated to increase 5x over the next 5 years, as shown in this chart. And our goal is to accomplish net zero imports towards the end of this decade. In the same time, the worldwide semiconductor industry is going through an explosive growth. It took 50 years for the semiconductor industry to reach $500 billion in revenues. In a mere span of next 10 years, it is projected to double its revenues to over $1 trillion. This growth is being fueled by the digitization of practically everything around us, and is multiplied by the launch of electric cars and autonomous vehicles that use hundreds and up to thousands of chips in each of these cars. In this slide, I'm describing various incentives that the government of India has laid out to kickstart the efforts on ground for bringing in this ecosystem. A very generous package of about $30 billion has been allocated for developing the electronics ecosystem in both semiconductors, systems, design, chip design, and also for upgrading the SCL fab in Chandigarh that India has. In the semiconductor display, which I'll go into more detail in next slide, we have allocated about $10 billion. The remaining 20 billion, 7 billions have been allocated for electronics manufacturing. There are production-linked incentives for manufacturing mobile phones, components, IT hardware. There are also various types of incentives linked to CapEx on components and sub-assemblies, as well as development of electronics manufacturing clusters in our country. The remaining $13 billion have been allocated for adjacent sectors: production-linked incentives for advanced chemistry cells, for battery technology for electric cars, automobile and auto components, telecom and networking, solar, photovoltaic modules, and white goods. Now, semiconductor is the core of where I am personally focused on, and there are $10 billion allocated for a variety of fabs, both for chip and display in this allocation. The total incentive, however, go up to about 70% once you take into account the various incentives that states are providing in terms of free land, utilities, power, water, et cetera, et cetera. So there's a very generous package to attract suitable partners from overseas to come in and help us kickstart fabrication and fab facilities in India. So our goal is to set up 2 display fabs and 2 semiconductor chip fabs. Also for compound semiconductors, which are needed for LEDs or also for power electronics, there is a desire to set up to about 20 companies. And for semiconductor design, which India is already very, very strong in, thanks to the presence of a variety of MNCs who are designing chips in India, with tens of thousands of our talented engineers helping them design them. We have also provided significant incentives to startups in India to design chips and help them deploy them in a variety of systems through a variety of different incentives in that arena. There's also a small amount of money allocated to upgrade our existing fab in Chandigarh, the Semiconductor Laboratory, SCL, and also explore the opportunity to not only modernize it, but also bring it into MITI, under the umbrella of MITI, and explore joint venture for commercialization of the operation of this particular fab. There are, however, quite a few significant challenges that we need to overcome to realize this big vision we have laid out. First and foremost is attracting credible partners for setting up chip fabs and display fabs in India. I just want to remind you that semiconductor industry has existed for over 50 years. And we are joining this particular race 50 years after most of the other countries have begun semiconductor manufacturing. The industry over the 50 years has consolidated quite a bit. It's only because as we've advanced the technology, the amount of money required to set up advanced nodes of these fabs is so humongous that many of the players that existed 30, 40, 20 years ago have gone the route of only doing chip design and outsource the fabrication of chip to countries like TSMC and Samsung and others. So our challenge here would be to attract credible partners, a handful of them that currently exist, to come to India to help us set up these fabs, bring the technology, bring the know-how, bring the expat talent, people who know how to run a semiconductor fab, bring the tools and equipment and the partnership that exists in the industry to build such complex fabs. The second challenge we have is developing a large pool of skilled semiconductor talent to support semiconductor manufacturing in India. Although we have tremendous pool of talent in information technology, and we are very well known in the world for that, we do not have today a large pool of skilled semiconductor talent in India. We'll be using this talent not only for our domestic needs, but since we have a large pool of talent in India, our desire is to create a pool that serves the needs of the entire global semiconductor engineers, and thus give us even more leverage to bring partners from outside who find us giving them something in return. The two biggest challenges of building a fab are first building the fab, and second is filling the fab. Now, in building the fab, we require 24/7, round the clock, 365 days a year, uninterrupted electricity, water, chemicals, materials, logistics, and even customs that have to really clear up movement of material overnight. Because one of the competitive edge various companies have is not only in providing advanced products and technologies, but very quick throughput time with which they move their products around the whole world where these supply chains exist. It takes about 12 to 24 months to build a shell and install the required equipment and tools, and an additional 12 to 18 months to ramp up the equipment and wafer fab to its full capacity. The other big challenge is once you have built this big fab, you have to fill the fab and utilize it to its highest capacity, over 90%, in order to make sure that the cost of what you're producing stays competitive. Typically, high volume products, which are in growing demand and enable rapid learning curve, are a good fit for filling the fab in the initial phase of bringing up capabilities in India. The other aspect of cost competitiveness comes from the yields. Not only you have to fill the fab completely, but each of the wafers that comes out of the fab has to be yielding over 95% of the good chips on them in order to be competitive with the rest of the world, which has arrived at those numbers over the last 50 years of learning curve that they have gone down on. Now, one of the ways that the semiconductor industry works today is there is a lot of intellectual property that's developed by various companies that have existed around the globe over the last 50 years. These intellectual properties are of use to different players for different products in different markets. And typically they are cross-licensed between them without paying any money to each other for use by each other. Now, for India to be able to participate in that type of a barter, it will also need to have a domestic R&D capability for developing new types of intellectual property so that they can also cross-license it with others and get their intellectual property without paying huge amount of licensing fee and money that will go towards increasing the cost of the product. So even though we launched this policy less than 8 months ago, we have made good progress to date. We have received 3 offers to set up fabs, 2 offers to set up display fab, 2 offers for packaging, 16 offers for designs of chip. We have set up techno-financial advisory groups in order to do due diligence on these offers that we have received so that we can decide which one of those meet our requirements. We have separate working groups that have been set up to address semiconductor design proposals in order to look at their validity and support them in terms of their CAD tool requirements and intellectual property core requirements in order to make those companies come alive. Then we also have set up a separate working group to prepare a roadmap for developing semiconductor talent pool in India. We have people from academia, industry, government, all involved in order to pull together this humongous effort that's required to make this vision come true. At this time, I will pass it over to Justin. You.
Thank you, Vinod, for that informative presentation.